Hello, today we will be solving another medium problem with a matrix. And this is a find valid matrix given row and column sums. So you're given two arrays, row sum, column sum of non-negative integer, where row sum is the sum of the elements of each row and call sum element of j column, okay, and to the matrix. In other words, you do not know the elements of the matrix, but you do know the sums of each row and columns. Find any matrix of non-negative integer with rows with size. Okay, so this is what unless unless. So this is the first step. What we have to do, is to define size of the matrix. Return to the array representing any matrix that fulfills these requirements. Guarantees that at least one matrix that fulfills the requirements exists. So we have row sum, call sum, and then we have 3, 0, 1, 7. And we have row sum, call sum, and we have 5 plus 1, 6. We have 6 plus 2, 8. We have 0, 8. We have 0. Okay, so obviously first step is to create result matrix. And create result matrix and init it with zeros. This will be the first step. Then what we have to do, we have to iterate, right? Then so in our case, rows will be len of row sum, right? Then calls will be len of call sum. And as we go through the matrix, we will take so 0 row, 0 column. So row 0, column 0. We will take minimum 3. Then row 0, column 1. Row 1, see, because this is 3. I believe that we have to take minimum from row. If we have, so the idea is if we have a like this, and we have matrix like this, so our result ij equals minimum between a row sum I and call sum j. So for example, 0, 0, we have 3. 0, 1, we have 0 because we already used 3. So we have to deduce it. So, and we have to do row sum I minus equal. So if this is our choice, then we remove it from here, right? Because we already taken 3 taken, so we are removing it. So that's our next mean will be 0. Oh, I probably have to remove from both row sum and col sum. And this is our, it will be our result, obviously. Ij equals C, and we return the result. So the goal is take a minimum number from row sum. So yeah, so then we will iterate double enclosed loops, right? We have for a row, let's call it R in rows. So we will have enclosed for row columns standard two loops. And time complexity for that will be n squared. But because we have relatively small matrix, just 500, it's not going to be a problem. So let's go and implement this. I'll just copy this into here. And second will be iterate. So how I would say it, it's like two enclosed loops, but for row and column. I want to name it properly, rows, column calls. And for that, we will take minimum number. And fourth step, okay, let's move it here. And fourth step, we will reduce step 0 will be calculate size of result matrix. Create result matrix, and init it with zeros. Create two enclosed loops for row and column. Take a minimum number and reduce So in this case, we will have, we can make this one. So this will be row column and row column. We need to have a let's name it P or maybe A. Sounds better. And yeah, that's it. Okay, results. Yeah, we have to create result, which is step 1. And the result will be how do I create 2? So multiply by rows, right? So this is we calculate in step 1, we are calculating size of the matrix, then we initializing it with zeros. For I in range calls, right? And it's a list of the lists inside. I think this one is, we don't need this one. So yeah, obviously row column. Yep. List index assignment is out of range. Row column. Rows calls. I think this is incorrect. Maybe this is incorrect. Yep. Let's try. Yep, and that will be it. It's pretty fast. Okay. I don't know why this one is faster. Oh, this is nice. So this is like optimized version. Yeah, I understand why it's faster. Cool. That's it for today. Thank you for watching.